Hello, I'm back to continue the proof to calculate the expectation of v squared. And here we have to define a new random variable that is I. I indicates that a certain path is belong to the bad edge. And so the random variable v will equal to the summation of all these edge and square it and take expectation, and we can expand it to be the same one and the different ones, and we can by symmetry take the two in here, and by linearity of the expectation we can separate into two parts. And the first part is easy because the square of indicator is still the indicator, so this one will equal to the expectation of v itself. And now we have to deal with the second part. And the second part is equal to the product of two indicators. That means that the ith edge is in the bad edge and the jth edge is in the bad edge. So we can expand it by a conditional probability, that is the first ith edge is bad, and given this one bad, the second one is bad. And now we have to deal with this part because this part is easy. Is bounded by delta that is equal to bad edge over good edge. And we have to compute this part. And after extract this part, and we take all the expectation. So this one will transfer into that we randomly pick a start point. That is, when this one means that this edge is in the bad edge, and we do random work for k-1, and the kth step is in the bad edge too. And because the random work itself is weak and stationary, so it's equal to pick an edge that is from randomly, and we do a random work to k-1, and to find out this one, the final step is the bad edge. So it's sufficient for us to compute this part here. And first of all, we have to compute that how to pick this one. This one will equal to that we randomly pick a bad edge and we find the start point. So the distribution of the initial point will equal to this one. That is the number, the degree of its bad edge, and to the all the number of bad edge divided by 2 because the endpoint has 2. And then we do the random work C to the k-1. So we do the random work k-1. And we can find that this is just the distribution of this part, just the multiplication of the random work vector to the vector of the initial distribution. And now we can, after defining these things, we can find the probability that the final step is in the bad edge. So the summation will equal to that summation over all the k-1 step, and to the final step that at this point he will pick a bad edge of itself. That is the probability, the number of bad degree minus all its own degree. Okay. So we have to compute this one. This one will become we can separate this part to here, that is, each vertex become each index of this one, indexed by I, and the summation by EVT, and this one will equal to here, that is shift. So it will become 2FDXV. That is, we can change the order to sum, to replace this one. Place one in here and divide it by D, and the number, and this one will become okay. So here we got a familiar thing here is equal to the inner product of X and the random work after K minus 1 random work. And this one will easy to compute after some observation. The first one is that the one known of the initial distribution is 1. So we can separate the initial distribution into two components. The first component is that is parallel to uniform distribution, and the second component is perpendicular to the uniform distribution. And the parallel component will become itself is just a scale of the uniform distribution, and perpendicular we can apply the spectrum of the random work. So this one will equal to so we can get this is the first part and this is the second part. Okay. Okay, so what we have to do is to compute the norm of X itself. And the norm of X is by this one, or smaller than someone here. And this one will become 1 minus 2. And this one, summation of this one will equal to F. So it will become this one. And the degree of V is smaller than total degree. So supply into here we got 2 to the F D 1 minus N plus lambda K minus 1 to the F D will equal to and this one equal to all the age. So subtract this one into this one here, we can get this one was smaller than the expectation of this one is smaller than epsilon delta square of t. Keep this one. And adding delta, that is from this one, and times this one, delta again. And which was smaller than 30, because epsilon is smaller than 1 over d square of t. And then we have show the value of this one. Oh, okay. And there is some final step. Remember, we proved that probability v bigger than 0 is and this proof is okay because where I is the indicator that y is not non-zero, and by quotient you will by quotient, and this one will become so this by some subtraction we can derive this one. So finally we can prove that the probability that the certain path is broken or equal or bigger than so here we finish the amplification of the arrow here. Thanks for your watching.